Okay, let's attempt one. Huh? Why not? How about it? Huh? Okay. So here we're gonna have, boy, in the figure below, 6e for Q1 and negative 11e for Q2 as separation D. What do we ask? With V equals 0 at infinity, what at what finite values of x is the net electric potential on the x-axis 0? Okay. So it's gonna have two. It's gonna have two. There's gonna be one over here somewhere, and then probably one here, right? This is gonna have a little bit more magnitude than this one, but they're gonna be attracting each other. Yeah, that looks about right, doesn't it? Maybe this one's closer. Maybe it's like sitting right here. But who knows? Could be anywhere, right? Right? That's the whole thing. We're trying to find them. Who knows? Right? Okay. So, what do we do then? Take a look here. This here, sir, is chapter 24, and at chapter 24, we've got a few equations. And we're looking for values of V. This is along a straight line. Got a dipole. Um, for first, let's find out what equation this is calling for. It's going to be KQ, yeah, V equals KQ over R. Except this time we replace R with a distance D. So we're going to have the equation KQ over D is going to be equal to, well, there's going to be two of them. So, at this distance here, we're going to have distance x, and then at this distance here, it's the other one, we're going to have x plus d. So let's add this. And in fact, let's call this just x, right? And this one's going to be q1, and this is going to be q2, and these we set equal to 0, right? Now what are we solving for? Well, we're solving for this distance here, x. So what we can say now is that KQ1 equals a negative KQ2. It's all going to be over x and x plus d. Now we can remove k from both sides. We have q1 over x, so this is going to be q2 x equals negative, or rather this would be negative, and this would be q1 plus d. The funny thing is, if we divide by x at this point, no, it could work. Let's divide by q1 and x. So now we have negative q2 over q1 equals x plus d over x. See, in my head, x is canceled now. That makes sense. X over x equals 1. Let's roll it back. We have this in this form. Really do want to get x isolated. I think this will work out if we add, let's see, q1. 6, what's 6e? 6 times 1.602 times 10 to the negative 19th, right? Yeah, why not? Okay. So this is actually going to be 9.612 times 10 to the negative 19x plus 9.612 times 10 to the negative 19d. And then, of course, this is going to be negative 11 times this. So this is going to be negative 1.762 times 10 to the negative 18x. Now we're getting somewhere. Now, what we could do is divide x's here and say that 9.612 times 10 to the negative 19d is going to be equal to a negative 1.762 times 10 to the negative 18 divided by 9.612 times 10 to the negative 19. These would both be x. So x would then, again, cancel. Wait. Okay. Why am I dividing? We can subtract. Could I have done that the whole time? Well, let's find that out. If I hold down, yeah, it goes faster if you hold it down. Okay. Now we just subtract these two. So we're going to have q1x plus q2x equals q1d. Oh, look, that's so much better. And we know what q1 and q2 are. So now we know that 9.612 times 10 to the negative 19 x, I guess it doesn't matter which ones, plus Actually, this would be minus. Wait. Yeah, it would be minus, wouldn't it? Because it's negative. 1.7622 times 10 to the negative 18 equals 9.612 times 10 to the negative 19 times d, which is times 0.028. Or no, times 0.28 meters. That's also x. So what happens when we take this and we subtract that? Now we're left with 8 negative 8.01 times 10 to the negative 19. Now if we x. Now if we divide this by the 9.61 times 10 to the negative 19, what if we do that times 0.28? So now we've got on this side 2.69 times 10 to the negative 19. We divide this by our 801 here. I'm getting that x equals negative 0.336. And that is in meters, and that's correct for the negative. Now, how do we get positive? I would say we flip what Q1 and Q2 are. So now all we do is we just say that's Q1, that's Q2, and you'll see this is evident because if we have this here, then this distance becomes x, and then that distance is d. So now, again, what we can say is that Q2 over x equals a negative Q1 over x plus d, cross multiplying Q1 x equals Q2x plus Q2d. Subtracting these two, we're getting this minus this equals this. And now when we plug in Q1 and Q2 equal, this is going to be honestly, can we take x out of this? This would be Q1 minus Q2 equals Q2d. So now what we have is x equals Q2d over Q1 minus Q2, which we can just plug and chug now. So Q2 is at 1.7, negative 1.7 times 10 to the negative 18. We're going to multiply that by 0.28, and that's going to be over Q1 is that 8.99, 9.6 1 equals 9.62 or 6. 12 times 10 to the negative 19, and then Q2 equals 1.762 negative times 10 to the negative 18. Now we're going to do that, and we're going to multiply. Let's see. 9.6. 2 times 10 to the minus a negative 1.762 times 10 to the 18. Uh-oh. Well, we got a negative answer somehow. Well, that don't make no sense. Hmm. Let me do this big old cross multiply again. That might be where I messed up. We're going to have Q1x going to be equal to negative. Oh yeah, Q2. That's going to be actually going to be plus, isn't it? Well, that didn't fix it. What the heck? Well, that would also be minus. Well, let's see. What went wrong here? Oh, you gotta be joking. I swear this is the right way to do this. Oh, where am I messing up? Hold on. I think it's here. I think I'm messing up here. Let's do this fully. Okay, Q2. If that's gonna negate and that's gonna negate, what if I just let's see. We're gonna have negative q1 x equals negative q2 x plus d. You can just take the negative out on both sides. And this becomes q2x plus q2d, which then this becomes equals, and it's going to be q2x. We pull the x out, and it's q1 minus q2 equals q2d. What in the world? Let me make sure that q1 and q2 are what they say they are. 6, yep. Negative 11. Yes. Both of those are correct. Let's try it with d minus x. Just let's see where that takes us. So now we are going to have q2 x minus q2d equals negative q1 x. So now we do, it's going to be q2x plus q1 x equals q2d. Take x out, it's going to be q2 plus q1 equals q2d. We have q2 times d over q2 plus q1 equals x. That is exactly what I got last time, isn't it? Yeah, wow. Goodness me, what the heck? Okay, I got it. We're conceptually wrong. Forget that there was an x here. No, the second place that it will be negated is here. So how would we represent this? Which kind of makes sense the way I drew the arrows. Gosh dang it, man. This would be q2 would be what? D minus x. And then q1 would be just x. If we're taking this point here to be x, which I think we are because this is situated at the origin. Okay. So with this then, q2 over d minus x equals negative q1 over x. So then q1x minus q1b equals q2x. Means that q1 minus q2x equals q1d. So now we're going to have q1d all over q1 minus q2. That's what x should equal. Okay. And this now is going to be all right. Yeah. So now we're getting the x equals point. Let's see. Yeah, 0.988 meters, and that's finally correct. Oh man, I was losing my mind. I was losing my mind.